We talked about the core network infrastructure services and the common applications on a network. Let's talk a little bit about the hardware components we expect to see on a network. Again, it doesn't hurt to have some background in hardware and software and system management. But even if you don't, maybe you're a project manager or you're a manager, you haven't gotten down into the nuts and bolts of hardware, you should be able to recognize these devices and know in general what they do. We'll talk, like I said, more about networking in the next lesson. So we have common network component types, starting with a repeater. And a repeater simply gets the signal farther. The repeater can be wireless or it can be wired, because the signal starts to just drop off in strength after a certain distance, and we want the repeater to boost the signal so it can go a little bit farther. And there's a whole sort of science behind how far you can have the repeater. You obviously don't have it way at the very end where the signal's very bad. You back it up just a little bit. But the idea is I want to get my signal a little bit farther than would be normal. So that's the idea of a repeater. A hub is a device, it's a central device, and it'll have multiple ports. It could be wired or wireless, and a bunch of computers or devices plug into it. Computers, tablets, phones, servers, printers, whatever. So this is a central device on a LAN that will connect a whole bunch of computers together. Now, hubs have been largely replaced by switches. A switch is actually a hub that's intelligent, because the problem with a hub is that I plug all these computers in. If one little computer transmits, a hub is obliged by its design to repeat that transmission out to all of the other machines, and maybe they don't care to hear that transmission. Whereas a switch, one machine makes a little transmission in here. The switch will take a look at the destination, where that transmission is actually supposed to go. It'll look at the destination address of that frame, and then it will selectively repeat that frame out, that transmission out, only the port to the other machine that's actually supposed to get it. So with a hub, if one machine's transmitting, everyone else has to shut up until it's done. But with a switch, if I've got a 24-port switch, I could, in theory, have 12 pairs of conversations going on at the same time. For the most part, we only use hubs if we really are kind of desperate or if we have only a few machines. But they still exist, and you can still buy them, but switches are cheap enough. Then there's a concept of a bridge. Now, depending upon your context here, Cisco refers to switches and bridges interchangeably because they do the same kind of thing. They make forwarding decisions based on layer 2 addresses, usually MAC addresses. But a bridge can also, if we think a little bit broader than that, we can think of a bridge as something that translates one media type to another. So I can have a bridge that translates from wired to wireless, or from Ethernet to power. And so that we can have actually transmissions of data over power lines. How do you like that? So bridges basically transmit, usually different kinds of physical connectivity, or if we think of the Cisco definition, they behave just like a switch because they basically are an older version of a switch, if you think of that sort of thing, where they make forwarding decisions between two segments of a network or a couple segments of a network based on destination layer 2 MAC address. So repeaters, hubs, and switches and bridges are all things we expect to find in the local area network to connect devices in the LAN. Then we have a concept called the router. And a router is a device that sits at the edge of your network and connects your network to other networks. And it makes forwarding decisions based on layer 3 addresses or network addresses. So I'm going to connect this whole network to the internet, or this whole network across a WAN link to that whole network there. And that's a router's job. A gateway is a more generic term. Sometimes when we say gateway, we're referring to routers. It is the thing that gets us to another network. Sometimes when we say gateway, we mean something that translates one protocol to another. So it's a little bit more generic term. We can have a gateway that will translate IP to IPX, or a gateway that is a router that will translate Ethernet to PPP. So gateway, though, is generally either a router or a function on a device that translates one kind of protocol to another in a network. Why do we need that translation? Because networks have all kinds of protocols depending upon the network, and sometimes we need to translate from one to the next to get from one network to another. And then finally, we have this concept called a modem. If you have DSL, you know what a modem is. Modem basically makes a dial-up connection across a network to some other location. A DSL modem is a kind of modem that never turns off, but you still have to authenticate, don't you? When you first set up a DSL modem, you provide a username and password. In the old days, the old dial-up analog modems actually picked up the phone, dialed a number, made a connection with the other end, negotiated a speed, and now you had a connection across an analog line. So that is the idea of a modem, that we make a connection. Now, it doesn't have to be across a telephone system. There are also cable modems. And with cable TV, your data is actually treated as a premium TV channel, one for transmit, one receive. And the modem then makes a connection between the cable system and your Ethernet LAN. Just so that you know what you're seeing when you see these devices, we're just going to look at some common examples. Here's an example of a repeater, and I can see that I have some RJ45 connections here for Ethernet. I can also see that I have some BNC connections. So this repeater is meant to just simply boost the signal so it can go farther. We, of course, can also have wireless repeaters as well. Here are some examples of hubs. You notice that most hubs these days are Ethernet hubs, and you can see the 8-pin RJ45 connectors here for twisted pair. These are just a couple of vendor examples. Here are examples of switches. We can see the much bigger, we can have whole racks of switches here. We can have smaller switches, and you might go, gee, that looks a whole lot like this. Are switches always sort of this greenish gray? Well, that just depends on the vendor. Sometimes it's really hard to tell the difference. Is this really a hub or a switch? But just by looking at it, unless you can read the product, sometimes you don't know. But here are typical examples of switches. And you can see up close pictures of we've plugged our cables. These are RJ45 jacks here, and we're plugging twisted pair. This looks like category 5, probably 5E connections into RJ45 jacks with twisted pair cable. Very, very typical for a local area network. This is, you'll probably recognize these computer cables. This is what you plug your computer probably into a port on the wall. Of course, one of the risks of having wired connectivity is that you can have a mess. I've been in places that were far worse than this, and they don't do anything about it until someone trips and some equipment gets yanked down on top of somebody. So part of good management is also good cable management as well. And you walk into data centers and you walk into server rooms, and there will be trays, and all the cabling will go along the trays and be have little panels over them, and it'll be neatly controlled rather than maybe something like this. Here are some examples of bridges. Now, this is an example of a wireless bridge. This is actually a USB to Ethernet. This is an interesting product here. It's meant to actually extend the length of your USB cable across an Ethernet link and then back to USB. I thought that was really interesting when I saw it. Here's an example of Ethernet to a power line. It'll actually plug into your AC outlet there so that you can run basically Ethernet on a power line around the house. So here are some examples of bridges. Here are some examples of routers. Here are the bigger professional routers, the big Cisco routers. Here are smaller branch office type Cisco routers, 7200 series, 2600 series. Here are the kinds of routers here that I expect to see at home. These are wireless routers. So here's an old Linksys. Here's a little bit newer one here. And you can see the ports on the back. Most of these routers, especially the home ones, they will have a little built-in switch inside of them. So there might be a little 4-port switch built in right here, and then you plug computers in here, plus it can pick up wireless from laptops and wireless devices, phones that are on Wi-Fi, and then you plug in your WAN link here. So here are some examples of routers. And here are some examples of firewalls. Here are the smaller firewalls, so these are Cisco ASA, and here's another one, a Sonic wall. And you might just say, gee, it is really hard to tell the difference between these products. Well, Yeah, you're right. Sometimes they look so much alike that it is hard to tell the difference because they all have the same kinds of ports and jacks. And that's why you have to actually look at the product and the name and the make and model to see, well, what is it really? Is it a switch? Is it a hub? Is it a firewall? What is it? I can tell at a glance, I know that SonicWall creates firewall products. But if I didn't look more closely at this, if I didn't know that this was a Cisco ASA, I wouldn't realize that it's a firewall. And so that's just sort of a quick look at different kinds of network devices that you'll expect to see when you are walking in and doing an audit of an IT department. Now, there are, of course, different system software types. We know we have operating systems. Windows Server 2012, Windows Server 2008 R2, Red Hat Enterprise. So there are all different kinds. There are also just database management systems, SQL Server, Oracle SQL. There are utilities and tools like the network monitoring tool or System Center. So there are a variety of different software types for whole systems, not just simply operating systems. When you are an IS auditor and you walk into an IT department, the things you're going to want to be looking at are, what is all the hardware they use? Do they even have a network map? Do they even have an inventory of all their hardware? Do they even know what all this stuff does? And do they know, have salespeople been plugging in switches and hubs that they bought at the local electronics store? Did they set up rogue wireless access points? What are all the hardware components? And sometimes that's a lot harder to answer than you might think. And then, how are they using and maintaining all the operating systems? Because there's going to be more than Windows. You're going to have Linux, and you're going to have Mac, and you're going to have different kinds of Unixes. There's all kinds of flavors there. And also, what about the entire network infrastructure? How are they controlling the traffic in and out to the internet, to other locations? What are they? How do they have their switches and hubs connected? How do they have their routers connected and configured? You'll want to review the entire network infrastructure. And if hardware is not your particular area of expertise, if network infrastructure is not your particular area of focus, you'll want to have with you people who really understand network infrastructure as well as hardware and operating system maintenance. And the next thing we're going to talk about is we're going to go deeper into networking.